How do we talk to computers? Well, imagine this is me, and I say to you, hello, my name is Sydney. What information do you gain? Well, you know I'm an English speaker, you know I'm introducing myself to you, and you know that my name is Sydney. Thus, you could reasonably respond, hi, Sydney. But what would happen if I were to say the same thing to a computer? Hello, my name is Sydney. The computer does not gain very much information from that sentence. Am I commanding it to do something? Am I asking it for some information? There's no way for the computer to know because while we speak in words, computers communicate in ones and zeros. So how do we talk to computers? How do we talk to AI? Well, back in the 50s, there were some very clever scientists trying to figure out how to convert Russian text into English text using machine translation, or MT. Their studies were some of the first efforts humans had ever made to study language computationally. Thus, the field of computational linguistics was born. Since then, a number of coding languages have arisen to help us communicate with computers. For example, Perl was invented by a linguist in the 80s, and it can handle a variety of tasks, but it still requires us to speak like this. For example, if I wanted to introduce myself, I might define and store my name in terms of a variable, then have the computer print a greeting in response. This is called structured text, and while it's still an efficient method of communication with the computer, it's not a very natural one. Thus, when we talk to Siri, Google, and AI chatbots, or we use Grammarly to correct our text, all of these programs utilize natural language processing, or NLP. We can think of NLP like a toolbox, and within that toolbox, we have quite a few tools. For this example, we'll try using just these three: tokenization, named entity recognition, and sentiment analysis. First, tokenization converts each of these 5 words into its own unique token, which allows the computer to process them as pieces of data rather than human speech. From there, it uses named entity recognition, or NER, to recognize Sydney as a person's name. Lastly, the computer may use sentiment analysis to understand that I'm introducing myself politely and amicably. Now that the computer has translated my natural language into structured text, the last step is to respond back to me using plain speech or unstructured text. There are a lot of ways to do this too, but the result is always a natural sounding response to my introduction. This simple interaction took years of work from computer scientists, engineers, and linguists. So the next time you have a conversation with an AI chatbot, or even use a spell checker, take a second to think about how natural language processing made it possible.